Hi everyone, my name is Julie and I'm currently a sophomore at MIT studying chemical engineering and computer science. For the past 4 months through the MIT-NCTU research program, I've had the opportunity to intern at the International College of Semiconductor Technology at National Chiao Tung University and work alongside two great mentors, Professor Tian-Li and Jethro Gallardo. And so this was actually my first time studying abroad, but in a remote setting. And so I hope one day I'll actually get to travel to Taiwan and meet everyone in person and also get to experience a little bit of Taiwanese culture. But yeah, despite not having the opportunity to do that right now, I still do have a lot of positive things to say about this internship. And so the first thing being the project that I worked on, which was focused on studying the TDDB phenomenon that occurs in gallium nitride high electron mobility transistors. And so I guess a little bit of context. Gallium nitride is still a relatively new material of interest in the power devices industry. And so a lot of research has been done to suggest that gallium nitride has stronger performance capabilities than traditional silicon-based semiconductors. But not much is really known about its long-term performance when it's implemented in actual electronic devices. And so before it can be manufactured, more research needs to be done to understand its reliability. And so my contribution was to develop a tool using Python for researchers who are doing these reliability studies. They can use this to analyze their TDDB data. And so the program itself uses a lot of statistical methods to make extrapolations of the collected data and use that to determine the expected lifetime of each device as a function of various stresses. And so through this work, I was able to develop a lot of my technical skills in data science, statistics, and of course programming, but also get to dive a little bit more into the physics behind power devices and learn a bit more about what's causing these limitations on a microscopic level. And so what I really liked was the blend of both, the physics side, which ties in more with the research and design process, but also the reliability study side, which is more of testing those ideas and making sure that they will work in a real life setting. And so the best part of the internship was this part because it gave me a pretty good perspective of the various stages of device manufacturing and also really good insight into what industry is really like. And so overall, I'm really glad I was able to contribute to this kind of research. And I want to thank Professor Wu and also Jethro for all of their guidance during this process. I know it can't be easy to manage an intern, let alone someone who is like halfway across the world. And so I really appreciate how welcoming they were and how accommodating they were of my interests, and also their effort in trying to make this experience as educational, but also as fulfilling as possible. And so for anyone watching, if you are interested in this kind of research, I would definitely recommend looking into opportunities here. Everyone is super nice, but I guess more importantly, they are really invested in your learning and they really do prioritize your interest because they want you to get the most out of your experience. And so if the research that I described piques your interest, I would really recommend checking this lab out. And so I really hope this video was able to offer you guys some insight, maybe into studying abroad, of what that's like as a remote intern, but also maybe also doing research in the field of power devices. And so with that, thank you so much for watching.